In this example, we're being given a function h that is defined by this equation here, and then they want us to find the equation for the tangent line to the graph of h at this specific x value over here. Whenever we're being asked to find the equation for a tangent line, this is really the same process that you went through in an algebra class to find the equation of a line. What we're always going to really want to be using is point slope form of a line. So the point slope form of a line looks like y equals m times x minus x1 plus y1. My form is a little bit different than a lot of teachers' formats, but the silliness is this is where your final answer wants to be. So this is by far the most useful way to memorize point slope form. So then let's kind of dissect what that means, right? So in order to use point slope form, we need a point. This is our x1 and our y1 right here. And then we need the slope. Remember, math people are not creative namers. If it's called the point slope form, it's because that's what you need to create the equation of the line. So we're looking for the slope here. Well, to find the point, let's kind of start there, right? To find the point of an equation, you're usually just going to take whatever the x value is that they give you and plug it into the equation, right? Plug in x, get out y. So in our scenario here, we were given x is pi over 2. And we were started with an equation right back up top here that told us that h of x is equal to the integral from pi over 2 to x of sine squared t dt. Well, this is function notation, and even though it's a funky integral, function notation always works the same, right? So if I want to plug in pi over 2 for x right here, then function notation says wherever I see an x in my equation, I'm going to replace it with that same value. So the x is one of the bounds on the integral. So if I replace this, this becomes the integral from pi over 2 to pi over 2 of sine squared t dt. And from there, we can quickly get the answer. The key to this problem on this piece was knowing that it doesn't matter what the integral is. You don't actually have to solve that. Whenever your lower bound and your upper bound are the exact same value, it doesn't matter what integral you're taking. The answer to that integral problem is always the same. It's always 0. So we now have our point that we need for our point slope form. We've got our x1 value right there, and we have our y1 value right here. Now what we need to do is we need to go find the slope, the other piece of our puzzle over here. Well, when you're finding slopes in calculus with equations, slopes come from your derivative, right? Derivatives give us the slope of the tangent line. So again, start with your equation here. So we've got h of x is equal to, and again we've got the integral from pi over 2 x sine squared t dt. And so, notation-wise what you're doing here is you're going to dx both sides of this. And once we do that, what we've got to sort of see happening here is like bells and whistles need to be going off that this is our fundamental theorem of calculus part 1. Whenever you see sort of this lower bound as a number here and then you've got an x or some other equation up there, the only time you ever see that in these AP Calc classes is when you're using this fundamental theorem of calculus. And of course, what that says is when I take the derivative of this side, h prime of x, that's just going to be a notation game. There's my derivative. When I take the derivative of the right-hand side here, remember derivatives and antiderivatives, that's what an integral are, they essentially cancel each other out. And so what ends up happening is that x value just slides down in place of that t value there. Derivatives and antiderivatives, it's like squaring a square root, right? If everybody has an opposite in math, right? And whenever I undo it, that x just drops straight out. And so here, the fundamental theorem of calculus basically says when I take the derivative of my antiderivative, those things cancel each other out, and that x is just going to drop into the equation. Well, now I need to find the value, right? So I go back, and again, I'm going to plug in the x value. I want to find the slope at that specific point. So I plug in pi over 2. This would be sine squared of pi over 2. And at this point, this is where your unit circle information needs to pop out of your brain. We need to know what is the sine of pi over 2. Well, pi over 2, when we think about our unit circle, is right up top here, and that's the point 0, 1. Remember that the x value in these situations comes from the cosine, and the y value comes from the sine. So this is pi over 2 right here. So what we can see is our y value is 1 at that position. And so the sine of pi over 2 is 1. So really what this would be saying is 1 squared, which is equal to just 1. So we have h prime of pi over 2. And now we have the last missing piece of our puzzle. We have our m, we have our slope. So if we grab everything we need, we grab our point that we got from part 1, we grab our slope that we got from part 2, and we plug everybody back into our point slope formula. So we get y equals m, which is our derivative value, which was 1, times x minus x1. So our x value that they gave us, that was our pi over 2. And then plus y1, our y1 value was 0. And so cleaning that up, 1 times anything just gives us itself. So this would be x minus pi over 2, and then plus 0 just leaves it as it is. And what we can see here is our answer would match up with option C. So remember, when you're finding the equation for the tangent line, you are going to be running through point slope form, just like you were doing in an algebra class. To find your slope, the slope is always going to come from your derivative value. To find your point is always going to come from plugging it into your original function. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.